Let's now focus on how to implement access control lists with OpenLDAP. We'll set up this section as ACLs with OpenLDAP and describe what OpenLDAP ACLs mean, which include, but not limited to, general and granular restrictions. So we can make basic restrictions such as anonymous has no access or all access to read, or perhaps access to a specific branch. Or we could get as granular as to limit one's access to one or more access to perhaps a single attribute, such as user password. So ACLs allow us to restrict access on a general broad basis as well as a granular basis. It also features a first match wins, like many firewall technologies. So the first, in a top-down fashion, the first ACL to match wins. So if you've got a series of ACLs, arrange them such that it makes sense in terms of the way the OpenLDAP processes those ACLs. So if you need to grant access or restricted access before more open access, then do so towards the top of the list versus towards the bottom. But all in all, the first match will win. Additionally, like with most firewalls, there's an implicit deny at the end of ACLs. The rule actually resembles a by star or by everyone, none or no access at the end of ACLs. And basically this denies access to whatever object is in question. So these are three simple features: the ability to limit on a general granular basis, the fact that the first match in a list of ACLs or in an ACL list, such as an ACE, an access control entry, the first entry matches, and that there is an implicit deny, which translates to by star, none. So keep these things in mind as you attempt to write ACLs. Now, ACLs basically follow the following template. And that is subject. The subject is generally a user, a named LDAP object. Permission, what to grant, such as the ability to write or read. And the object, the LDAP entry that you're protecting. So generally you can think of this tuple, or this triple, that is, three separate components: subject, permission, and object. You'll see it throughout OpenLDAP documentation more commonly as access to what by who, and the permission. So the who would be the subject, the permission is the permission, and the what is the object. So let's just indicate that. The subject is the who, which can be a user, and is often a user, but may also be a group or any other OpenLDAP object. The permission is the permission, level of access, and the object is the what, also known as access to what by who followed by the permission to be granted. We like to write it as subject permission object because it's much closer to SE Linux or security enhanced Linux object permission definitions. But nonetheless, the concepts are pretty much all the same. Now, to further elaborate, let's break out each of the individual items from the triple, beginning with subject. Subject can be a wildcard, such as asterisk, as we're indicating here. This means any particular subject, whether it's an LDAP user, all groups, etc. The subject may also be self. This is the authenticated user to LDAP, to OpenLDAP. The subject may also be anonymous. An anonymous subject is, of course, a subject that has not authenticated. So let's indicate that anonymous means exactly that, non-authenticated user, which is whom we have been authenticating as all along. So in our LDAP searches, for example, we've been indicating LDAP search by and large without authenticating. That is the default permission provided by OpenLDAP, and that is to allow all users the ability to at least read the contents of the directory, with the exception of one or two attributes, which we'll take a look at momentarily when we examine the default ACL. So we've got asterisk, which means wildcard, self, which means the authenticated user, the user currently logged in. We've also got users, which also means authenticated. And we've also got a specific DN, and we'll just indicate an ellipsis to mean any particular DN, so the distinguished name of an object that's currently making use of the directory, perhaps for read, write, etc. As far as permissions are concerned, we are able to work with the following. Write, which means that the possessor of this permission is able to make changes to the directory space where write permissions have been granted. So it may be from the top down, or at a specific branch, or at a specific organizational unit. There is read, search, compare, which allows comparisons to be performed, authenticate, and none. These are the permissions that we are able to work with. Permissions that grant more access include, by default, lower permissions. So write by default grants read access. It also grants search access. Search access, however, does not grant read access. Read access grants search access. If you have write access, then you also have, unlike many file systems, you also have read permissions. An object, as we alluded to earlier, can be a wildcard such as asterisk, which means all connecting entities, anonymous or not, or it may be as specific as DN, a specific DN, or it may follow a hierarchy such as dn.children, which means children objects of a given parent, equal to, perhaps, let's say OU equals people. So all of the children of OU equals people, for example, can be lumped or can be referenced as an object in a ACL. So if you wanted to grant permissions to an object branch, such as an organizational unit, this would be one way to do it, to indicate DN followed by children, followed by the name of the top level object, and the permissions would be granted to everything within the people OU. These are just only some of the ways you may specify object, wildcard, or specific hierarchy representation. But in general, when writing ACLs, you're dealing with this triple of subject, permission, and object, or to use the OpenLDAP documentation terminology, access to what, by who, and permission. Now with that said, let's set up as our first task to examine the default ACL. We can pick any of our servers. We'll pick the SUSE 2 box, since that's the window that we have open, and we can either grep ACL or use nano to modify the slapd.conf file. And by the way, let's just include that in our features list. ACLs are stored in etc OpenLDAP, or more appropriately, simply slapd.conf, as slapd.conf's location will vary depending on distribution. So once in this document, navigate towards the bottom, and you'll find the access section as it's derived. Here we see the default ACL that's included with SUSE 10. Now, as we've mentioned, access control entries are cumulative. They form a list, and slapd will process and match items top down. So the first rule that we see, access to dn.base by *read, basically means access to the base of the directory by anyone. So access to what, by who, and permission. The permission is read. So anyone may connect to the base and read the contents of the directory at the base. Access to sub-objects of the base, for example, indicated by CN equals subschema, are also viewable by everyone with the permission read. And asterisk also includes anonymous, in addition to authenticated users and specific distinguished names. We also see two ACLs or ACEs in the ACL which appear to focus on attributes. That's another neat feature of ACLs, the ability to limit access to one or more attributes. Now here we see access to attributes and a list of 2 attributes. This tells us that when accessing user password as well as user PK CS12, which deals with encryption and digital certificates, by self, the authenticated user that's currently logged in may be able to write or will be able to write to those attributes. So if a user is logged in and wants to change the user's or one's password, one can, because this permission by self permits write, which means OpenLDAP keeps track of who's authenticated, and if you attempt to manipulate either of these 2 attributes as yourself, for yourself, then you'll be able to. But for everyone else, it's used simply to authenticate, and that's what the next line tells us. So for other users, we can attempt to authenticate. So what this means is when we initially connect to OpenLDAP, we're anonymous. Until we have authenticated, we are not authenticated. We are anonymous. So anonymous users should at least be able to attempt to authenticate, and that's what this line does. By *auth, it permits anonymous users the rights to at least attempt to authenticate using either user password or user PK CS12, which again references digital certificate authentication. Now moving on, we see access to attributes equals shadow last change. Shadow last change is a field which is represented in etc shadow but re-represented in LDAP, and it keeps track of the last time the object's entry was changed. It's stored as a shadow last change attribute. Just like with user password and user PKCS12, the owner of the object can write to it, but everyone else can only read it. And last but not least, there's an ACL, access to all, by all, read, or access to everything, by everything, read, which is the catch-all permission which permits anonymous users the ability to search the directory information tree without restrictions. So with that said, what we want to do at this stage is to practice with some ACLs, set up some simple tasks to see how ACLs really work. So our next task is to restrict DIT access to what we have referenced as authenticated users. That means users who truly have accounts, and that means no anonymous users should have access. So this is a simple way of disabling anonymous access to the directory. Now the ACL needs to follow the syntax that we've laid out thus far, which includes the following: access to what, by who, or subject, permissions, object, triple. So we're going to define it between single quotes as access to star, which means everything, the entire directory information tree, by users. By referencing users in the who section, we really mean authenticated objects, authenticated principals. So access to star by users read will ensure that only users who are authenticated can read information from the DIT. Let's copy and paste this. Now, by the way, if you notice, my ACL is on one line, but the ACL entries in slapd.conf are on separate lines. Another feature of access control entries is that you may indicate them on separate lines so long as you start the separate line with a leading space, at least one leading space. Now, in order for this to take effect, we should comment out the existing ACL, which provides full access, full read access, that is, to the DIT, to all users, including anonymous. Now we can confirm that. Let's save the changes to the slapd.conf and in a separate window confirm it. We'll su in, or in fact let's connect to the remote system. And let's get an LDAP search from our history. And we'll use item 872. This will allow us to search the directory anonymously for any type of object from the people OU level down. So there we can search as an anonymous user, no problems. We have not had to authenticate. But momentarily we will have to authenticate now that we've made the ACL change. Now for the ACL change to take effect, we must restart the server. So note, restart/reload open LDAP after making ACL changes. And again, just to confirm our change, let's navigate back to the window that we've got open. We have commented out access to star, or to everything, by star read, and have included a new entry, access to star by users, which means authenticated read, which means anonymous users will be unable to read DIT entries. Now let's close or find a spare window and restart open LDAP. We'll do it in this window. And this will restart it momentarily. And then we'll return to our search, which is in our history, as anonymous, and there you see it fails. It doesn't allow us to search the people OU. Let's try from the base of the DIT, and that too fails. It returns nothing, not even the top level organizational units. So as it stands, we have a simple ACL which will not permit anonymous access or restrict anonymous clients from querying the DIT, which is the suggested way of erecting your LDAP server, by the way. You should only permit authenticated users the right to search the DIT, as the DIT may contain sensitive user information. Even if it's only address book related information, it's still private, and you may be violating various privacy laws, etc., if you don't protect that information, or at least restrict it to authenticated users. And you can get fancy and restrict by groups using ACLs so that perhaps members of only certain departments can view certain members of various departments and the like. But this is just a simple example of what you could do. Now, let's prove that indeed an authenticated user is able to query the directory. We need to authenticate, of course. So as a substep, LDAP search as authenticated user to the directory. Now a simple example of that would be to authenticate as the root DN, but we could as any other user so long as we have the user's password. Now to bind to the directory information tree as another user, we need the -D option followed by double or single quotes, and in between the full name of the connecting user. So we'll use cn equals manager. This is the distinguished name, of course, and dc equals internal. Now we also need a -W option to prompt us for the password. And there we see all of the objects in the base directory. And there's been all sorts of replication and causing the numbers to go up, which will rectify. And if we wanted to narrow the scope, OU equals people, it prompts us again, and it returns only the appropriate people. Now, of course, if you have credentials for other users, such as, let's say, proj user 3, let's try this user out. This will still prompt us for authentication. And it doesn't take the password. Let's try it again. And it doesn't like the credentials. And that's because our DN is incorrect. We were doing it so quickly. The DN should be UID, and we need the OU equals people. If we try it without, it won't work. So let's include OU equals people to indicate the full path to proj user 3. And now it dumps the content. So Only authenticated users can return information from the DIT in this particular configuration. Be sure to indicate the full DN, as we did not for the first 2 tries, of users in various OUs to confirm DIT connectivity. Now, what if we wanted to be less stringent by allowing anonymous the ability to query perhaps the host's OU? Supposing we want anonymous LDAP clients out there to at least get a list of hosts that are available within our network. Then we'd need to alter, of course, the ACL. Let's define as our third task, allow anonymous access to hosts OU and nothing else. So what would that particular ACL look like? This is an opportunity to use the dn.children specification. Again, no need to memorize it, just man slapd.conf where you'll see example usage of ACLs. But the ACL would resemble the following. Again, it's access to what by who permission. So access to dn children. We want to be able to have the anonymous user return all children objects of the host's OU. So access to dn.children is equal to OU equals hosts. It can be single or double quotes. Either or doesn't matter, but since we use single on the outside, we'll use double on the inside. The full path. And we'll say that by star read, and we'll be sure to include this permission first, followed by the second requisite permission to ensure that the user isn't granted access, but it's good to specify it explicitly, and that is access to star by users read, because the default implicit deny will deny reads. So just to recap, access to children objects of the OU hosts, which is beneath the base DC equals Linux CBT DC equals internal, will be permitted to all users indicated by the asterisk, and the permission will be read. But then access to everything else requires that you're a legitimate authenticated user, and you'll be able to read, if indeed you're that user. Let's find our window where we have slapd.conf open. We'll comment this out here, paste our new permission, and then paste the second line, which is exactly the same, but just to keep them separate so we show the various instances. So now we've got a new ACL. The ACL includes the entries above that are currently uncommented, these ACLs which restrict access to specific fields like user password, user PK CS12, and shadow last change, and then our new permissions of children objects. Let's save the hosts OU, that is. Let's save the changes and restart the service. This will restart LDAP. Let's try to perform a search, a modified search, as an anonymous or the anonymous user, indicating OU equals hosts, and if there are any items in there, they'll be returned. Only the organizational unit container exists, so it at least is returned, which is what we expect. So we can restrict on a per OU basis. How about a different OU, such as one that we know that definitely has items, such as services? OU equals services. And we'll restart in a separate window here. Then attempt to search hosts. This time returns nothing as expected, not even the top level OU. But if we change this to services, it returns all the services. If we remove, for example, the services OU for which we explicitly have access, and attempt to search the base, what's returned are the list of services. So this is a recursive search which can only search the services OU. If we try to search, let's say, the people OU, nothing's returned. But if we attempt to search as an authenticated user, the people OU, it returns the items. And if we also attempt to search as an authenticated user, the hosts OU, it too will return the appropriate items. Let's try that password again. And we indicated the wrong. This is OU equals people. We changed it in the wrong section. This should be OU equals people. And the search field needs to be changed to be hosts. And there we see the definition of the OU, which returns one search match. Let's try it for services. And it returns all the services. So you can definitely keep anonymous out or restrict anonymous to specific items. Now, what about being more specific, such as restricting on an attribute level? So restrict access on an attribute level. So for example, what if we wanted to restrict from the people OU? Let's take a look at what's returned when we dump the people OU and find something to restrict. So here's a dump of the, and this is OU equals hosts. We need people. Here's a dump of the people OU. We can pick any of the attributes listed and determine that we'd like to disable access to the attributes. For example, supposing we didn't want to publish the login shell attribute for fear of a security compromise. Perhaps if a compromise is, or if a compromise is to be launched, it could be premised hypothetically based on vulnerabilities in a given shell. So supposing we're being very extra secure and we want to limit the shell. Since the shell isn't important to the casual user anyway, well, we could limit access to the shell, to this attribute. We can limit it to everyone, for example. The ACL would resemble the following: access to attributes equal, and the name of the attribute is login shell, by none, by star none. Again, this is access to what, by who. We could compound the ACL so that self has access, but no one else has access. So at least when the user logs in, they're able to read their login shell. But this is a way to disable it. As we see it in the output when we ran LDAP search as an authenticated user, we could then decide to one by one filter or restrict the attributes that are visible. So let's find our slapd.conf and make that change. And here we see the access to DN. It can compound if we'd like. Anonymous definitely doesn't have access, but we should place it before access to star by user's read. This will ensure that the match will apply first, so that when OpenLDAP formulates the output and returns it to the caller, it checks this ACL and doesn't return it to the authenticated user, with the one exception being the root DN, that user being manager, for which nothing is restricted. Let's save the changes, and in our third window restart the OpenLDAP service, which should be in our history here somewhere. Let's find our recent search. That's of the hosts OU. This one's of the people OU. We're looking towards the right here. And this will prompt us for authentication. And now notice in the output, when it's dumped, we no longer see the login shell for any of the users that are reflected. We authenticated as prod user 3, and even prod user 3 is unable to read his login shell. Now, of course, we could adjust this so at least self is able to read it. Let's take a look at that modification in our window. What we would want to do here is spread the ACEs out a little bit. So let's move this down and move the by on a separate line. Here's a useful application of a separate line. So by star none, but again, as we've mentioned, ACLs are processed top down. So before we get to by star none for this particular ACL or this particular ACE in the ACL, everything composes one ACL, we'll include a separate rule. By self, read. This means if the object return corresponds to the currently authenticated user, then display it. Otherwise, do not. And then we'll copy this and paste it into our notes after it works so that we have a simple example. We'll save the changes and then restart, open LDAP, and then reperform the search. So let's clear screen here. And this will search the people OU again after we've authenticated. And now if you take a look, for the user for which we authenticated as prod user 3, we can read the login shell. But for the other user above this user alphabetically, like CBT, Sun Local 1, or, yes, in this case it is alphabetical, we cannot read the login shell. And if we scroll up, that'll be true for the other users. So this is the sort of granular security that we were mentioning. And again, you can stretch this even further to restrict items. Notice also user password shows up for the user prod user 3 who initiated the search, but not for LCBT Sun Local 1. And that's because of the default rule in the SUSE build above, which restricts access to the user password field. So here you see that user password and user PKCS12 may be used to write if by self, or only for authentication, not for read by anyone else. If we wanted to restrict access to other attributes or fields such as UID, we simply could just extend your ACL to include that additional field. So perhaps we'll paste in our item here as attempt B, and we've got the wrong thing copied, so we need to get it from slapd.conf after we scroll down. And if we wanted to apply this particular ACE to multiple fields, then by all means use a comma to indicate the additional fields, such as UID. Let's modify it and take a look at the effects. Save the changes, restart the LDAP server, and then you'll see momentarily that also UID is not accessible, with the exception of the user who currently authenticates. So notice for the user LCBT Sun Local 1, we cannot see the login shell field. We are also unable to see the UID field. So both fields are off limits. But for the user with which we authenticated, we can see both login shell and UID. So storing your information in a database such as LDAP allows you this sort of flexibility that you simply don't have with flat files. With a flat file such as etc shadow, it's all or none. It's either you have access based on the file system permissions or not. Whereas with LDAP, we can get very granular and write very in-detailed ACLs to cover our needs. So we've covered a little bit, just touch the surface to show you what's possible. We've disabled anonymous, enabled anonymous for the hosts and services OUs. We've also restricted access to specific attributes. Beyond that, it just becomes whatever creation or whatever formation is necessary to suit your environment. Now before we go, we should point out that the changes made on the primary server do not impact the other servers that perform or partake in replication. So we've made changes on the primary server SUSE Enterprise 10, but the Red Hat and Solaris boxes have not been impacted, which means if we take a search that we've performed here and perform it against the remote system, the attributes that we've limited, such as login shell and UID, will be revealed. For example, let's indicate host Linux CBT serve 4, And let's try it by IP address. And there you see the UID is returned for the other user as well as the local user. So here's UID for LCBT Sun Local 1, as well as the login shell. So let's just note that in our notes that you have to apply ACLs across all replication partners. So note, ACLs apply to, or apply on a per server basis. Copy ACLs to replication partners if necessary. Otherwise, one could query a replication partner and return information they should not be allowed to. Again, simply taking the ACLs from one system to the other will do the trick. Let's try to ping Linux CBT Sun 1. It responds. If we attempt this search against the remote system Sun 1, it prompts us for authentication and returns, as mentioned, the UID for each user. The ACLs can be copied directly, however. Let's find it, and here we see access to the appropriate attributes, then access to star by user's read. So let's copy this and paste it on the Red Hat box. Open LDAP as the same directory, slapd.conf, and we'll find our ACL section. And it's here, so we'll paste it in this particular area. This will permit the access similar to what we configured on the SUSE side. Let's save the changes and restart LDAP using service LDAP restart. And ditto on the Sun box. Let's find a spare window open here. And it's in user local etc. Open LDAP, we'll modify slapd.conf. Search for access to. There's a section that's commented, and we can paste it there unless we see other access to directives defined, but there are none. And of course this means we'll have to kill the existing instance, then history grep, slapd to find an instance to start, and we'll run the instance 493 to restart it, and psef grep slapd. Now it's back up. So something to keep in mind, that ACLs must be copied across, otherwise they will not take effect across the board. You could of course share your config files if you're using some sort of file system like AFS or GFS, and mount ETCs or directories where the config files are shared, but nonetheless ACLs generally are not changed often, so there's no big deal in copying them across.